Hey everybody, this is Mr. Farrell here, and we are going to be working with vectors today. So this video is going to go over a couple of things. First of all, what is a vector, how to draw a vector, how do we add vectors, and then how do we use Pythagorean theorem with vectors. All right, it might end up being split into two videos, so we'll see how far we get. But for starters, whenever we're working with vectors, we're dealing with directions. So I like to start off by just drawing myself a little compass rose with all the cardinal directions on it. All right, so I've got north, south, east, and west. All right, and the way I remember how to write east and west is it always spells we when you look across. Also, one of my students said, never eat soggy waffles. So you can walk clockwise and you'll know how it's supposed to look. So never eat soggy waffles. Great. So that's a really cool way to remember it too. All right. So first of all, what are vectors? Vectors are quantities that have both direction and magnitude. Normally, we're used to working with things we call scalar quantities, which only have magnitude. For example, what temperature is it? Let's say it's 70 degrees Fahrenheit, right? Or 20 degrees Celsius. Someone asks you what time it is. You could say 4:10 p.m., right? All of these numbers are they're scalar quantities because they're magnitudes. They don't have a direction necessarily. All right. Now, when we talk about vector quantities, we're talking about things like velocity, displacement, acceleration, right? Forces, all of these things have directions associated with them. For example, if we're traveling 20 miles per hour, that by itself is a scalar quantity because there's no direction associated with it. But if we were traveling 20 miles per hour north, then it becomes a vector quantity. All right. So if we want to draw vector quantities, all we have to do is draw the direction using an arrow, and then we write the number and the units underneath. For example, we could say something was traveling at 10 miles per hour north. So we draw a vector going north, and we write 10 miles per hour, okay? Or we could say that someone walked 30 feet east, okay? So we draw a vector east, and we write 30 feet. All right, let me make that a bit longer. All right, or we could say let's say something was accelerating 5 meters per second squared south. So we draw vector 5 meters per second squared, right? And the vector's pointing south. Okay, and the same thing would be the case if we were drawing a vector going west. We just draw the vector arrow west and the magnitude. So for example, if something was it walked 2 miles west, then we draw a little vector, right? And we put 2 miles, and it's pointing west. Okay, great. So one thing I want us to notice about these vectors is that the length of the vector's arrow gives you a hint at the magnitude. So the longer the arrow, the larger the magnitude. And you can see that here. The magnitude of this vector is 10. All right, the units are miles per hour, so we know it's velocity. But the magnitude is 10, and it is pointing north. Right, now let's take a look at this. Now these are units for acceleration. So two different quantities. They are not the same. But this one only has a magnitude of 5. So as you can see, this vector arrow is about half the length of this vector arrow. Okay, we can see that the arrow with 30 as its magnitude is way larger than the 10 or the 5. And then the arrow with 2 as its magnitude is very small. It's even smaller than the 5. So the length of your vector should match up with the magnitude, okay? And in my class, I'm not too strict about it. You don't have to be precise, but you could use a ruler or a graph paper to make sure that this vector was exactly 3 times the length of this vector. This vector should be half the length of this one, So Now that we have our vectors, a couple examples of vectors drawn, let's talk about simple adding and subtracting of vectors. Okay, so we're at part 2 in the video now. So for starters, for simple addition and subtraction of vectors, you can only add and you can only combine vectors that are along the same plane. What I mean by plane is we've got a north-south plane, and then we have an east-west plane. Okay, so you can only combine vectors using addition or subtraction when they are along the same plane. Okay, so for example, the 10 and the 5, now these vectors have different units. So actually, let's do a little change. So I'm going to make this, we'll be working with displacement right now. So I'll make this 10 miles and this 5 miles. All right, I'm going to change that to feet. Okay. Actually, let's change it to miles. Let's change everything to miles. Okay. 30 miles and 22 miles. Okay. So I can add or subtract 10 miles and 5 miles because they are both in the north-south plane. I cannot add or subtract 10 miles and 30 miles because the 10 miles is in the north-south plane, the 30 miles is in the east-west plane. So I'm going to have to use Pythagorean Theorem for that, which we'll get to later. But all that is to say you can only add or subtract the vectors that are along the same plane. So they both have to be in the north-south plane or they both have to be in the east-west plane. Now let me draw up a couple vectors. I'm not going to write the magnitudes just because I want us to do a little bit of practice with this. Okay, so what I've done here is I've just drawn a couple different vector combinations, and we're going to walk through whether we can add or subtract them. Okay, so these vectors, we have one going north, one going west. We cannot add or subtract those because they are not both along the same plane. Here we have a vector going north and a vector going south. We can add or subtract those because they are along the same plane. Here we have two vectors going north. That is still good. We can add or subtract those because both vectors are along the same plane. Here we have a vector going south and a vector going west. We cannot add or subtract those because they are on different planes. And here we have a vector going west and a vector going east. We can add or subtract that because they are both along the same plane. Okay? All right. Now, let's go ahead and practice actually adding vectors together. So we know now we can only add them if they are along the same plane. All right, so let's work with the north-south plane. I'm going to write that up here just so we're familiar with what we're working with right now. So if vectors are in the same direction, we add them together. If they are in opposite directions, we subtract them. So same direction equals addition, opposite directions equals subtraction. Okay? So let's say we have a vector going 5 miles north and we have one vector going 2 miles south. Notice again how I drew the 2-mile vector smaller than the 5-mile vector because the length of my vector should represent the magnitude. Okay? Now these vectors are in opposite directions, so I'm going to subtract them. Okay? Whenever I do vector subtraction, I want to start with the larger vector. Always start with the larger vector. Okay? So I'm going to do 5 miles minus 2 miles. Okay? And that is going to give me 3 miles as my final magnitude. Now, how do I know what direction it goes in? Again, I'm going to go to the larger vector. Whatever direction that vector was in, that's the direction that final answer will be in. So 3 miles north. Okay? Now, this whole situation works the same way if these vectors were east and west. So let's say I had 5 miles going east and 2 miles going west. Okay, again, these are opposite directions, so I am going to subtract them. I'm always going to start with the larger vector. So I start with 5 miles minus 2 miles, still gives me 3 miles, and the larger vector is going to be my final direction. So I'll be going 3 miles east. Okay, now let me go ahead and erase this. And we're going to do an example of them being in the same direction. So let's say we have two objects. Let's say one object is driving at 3 miles per hour south. And let's say the wind is also blowing at, let's say 7 miles per hour south. Okay? Because both of these vectors are in the same direction, we know we're going to add them. You can always start with the larger vector though. So we put 7 miles per hour plus 3 miles per hour. And that's going to give us 10 miles per hour. And again, the direction of the larger vector is going to be the final direction. But really, because both of these vectors are in the same direction, that's why we end up with it going south. Okay? And again, the 10 vector is going to be larger than the 7 or the 3. Okay? Great. And the same thing would work if you were heading east, if both vectors were going east or both vectors were going west, etc. Okay? So, now we know how to add vectors. All right? Now, we may split the video here and continue on with a separate one, but I'm going to keep going. So, now we're on step 3, adding multiple vectors. So, this tends to be a challenge for a lot of people, or some people. But really, we're just doing step 2. There are just a couple more steps that we have to do in order to solve the problem. So when we're adding multiple vectors, before we do a word problem, I kind of just want us to see the principle behind it. So let's say, first of all of our vectors need to have the same units, otherwise we can't add them, right? So let's go with feet. We're going to be working with feet. So let's say we have 4 feet south. We have 3 feet heading north. Let's say we have 2 feet also north. And let's say we have 5 feet heading south. Okay? So, I've got a lot of different vectors up here, right? In order to add multiple vectors, what we are going to do is combine the vectors that are in the same direction first, and then we're going to add everything together. So right now we have 4 feet and 5 feet that are both heading south. Okay, so let me go ahead and add those. So 5 feet, we start with the larger vector. 5 feet plus 4 feet is going to equal 9 feet. All right, and both of these are heading south. So still direction of the bigger vector. Both of them are heading south. We'll say south. Now, let's go ahead and add our other vectors together. So I have 3 feet and 2 feet. So 3 feet plus 2 feet equals 5 feet. And both vectors are north, or you can go direction of the larger vector, still north. All right, so now we have broken our problem down into 2 vectors. All right, we've reduced everything to just 2 vectors. First, we combine all the vectors that are in the same direction, and now we just have 2 vectors left. So we have our 9 feet going south, our 5 feet going north. Now, because these are in opposite directions, we're going to subtract. So we start with the bigger vector. 9 feet minus 5 feet equals 4 feet. All right, and the direction of the larger vector is heading south. So our final answer is going to be 4 feet south. All right. Awesome. So that's the same way we would do it with any word problem. Okay. Now we need to learn the Pythagorean Theorem method. So some of the problems that I like to have students do in my class that are kind of tricky are you're going to add multiple vectors together. All right. But you're going to end up with one vector going north, one vector going east. So they will not be along the same plane. So then you will have to use Pythagorean theorem to solve the method. So let's actually go ahead and do that step by step. So I'm going to go ahead and pause this video and then try to add a piece on later.